So we are still in chapter 3.6, which is on free fall equations. And so free fall, we know, is if you've got a ball, an object or a ball, and you just drop it down, okay? But this problem is actually a projectile motion problem, right? Projectile motion, we throw it up and it comes down. So a stone is launched straight up from ground level at a speed of 8 meters per second. 8 meters per second. How high does it rise? Okay, so how do we go about solving this problem? Well, the first thing that I know is that my acceleration is minus g, and it's constant. So because it's constant, I know that I can use these equations, plus v initial t plus half at squared. V final is v initial plus at, and v final squared is v initial squared plus 2a delta x. So these are my three equations, my three constant acceleration equations. So as I said in the previous video, please don't go and memorize, where is it now? Please don't go and memorize equations like this, okay? Just know these three equations and apply them to your specific situation. So these are your generic equations. Position as a function of time, velocity as a function of time, and velocity as a function of position. These are your three equations. Now take these and apply them to your specific situation. A stone is launched straight up from the ground. So I've got position information from ground level, I've got velocity information, and I've got that it's a projectile motion problem. So I've got gravity. So how about I take this one and apply it? So what is my final position? Well, that's what I'm looking for. What's my initial position? 0. What's my initial velocity? It is 8 meters up times time. And what is my, I've also got minus a half times gravity t squared. So I've got two unknowns here. I've got time and position. What about this one? 2. What is my final velocity right at the top? We know it's 0. My initial velocity is 8. And I've got minus gt. Okay? So there I'm able to then solve for time. So I've got two unknowns in this first equation. In my second equation, I've got one unknown because g is, I know g, so we can solve for time, and we get 0.82 seconds that it takes to reach the top. Okay? Then I can take that and plug that into there, and I can get my final height of 3.3 meters. The other way is just to, if I'm not mistaken, is to use this equation. There I've got velocity information, and I've got my acceleration, and I've got position information. So I'm looking for position, but I've got velocity. So with these two, I first had to solve for time and then solve for position. With this, I can solve directly for position if I've got my initial and final velocities. Okay? So how high does it rise? We've got it. My final position is 3.3 meters. Now what is the second question? How many seconds does it take for the stone to hit the ground? Well, because it launched from the ground up to the top and down again, and it's 0.82 seconds to get to the top, then we just double that. And so we will get, where is it? We will get 1.6 seconds. All right? So I hope that helps. See you in the next video.